Hello friends, today we are going to talk about the very common terms, okay, which is called UV visible spectrophotometer. Already on my channel I have a lot of videos that talks about UV visible spectrophotometer, okay. So this is just the theoretical part about the use and application or principle of the spectrophotometer, okay. Now there are a lot of variations on the UV visible spectrophotometer, okay. And basically the word UV visible photometer is that uses a light source, okay, to illuminate a sample with light across the UV to the visible wavelength range that lies from 190 to 900 nanometers. And this instruments measure the light absorbed, transmitted, or reflected by the sample at specific wavelength, okay, or you can say each wavelength, okay. Now the principle of the UV visible spectrophotometer is based on the absorption of UV light or visible light by the chemical compounds, which results in the production of a distinct, or you can say a specific kind of a spectra. And this spectroscopy is based on the interaction between the light and the matter, okay. Now in the second diagram, as you can see that we have on the extreme right, we will talk about first, then we'll talk about the qubit. So we have the light source, okay, and the diffraction grating, silt, and a rotating disk, and a sample self, and down we have a reference self and a mirror, rotating disk, and a detector, okay. Now if we break into simpler terms, so we have a light source, okay, and wavelength selector, and a sample and a detector, and a computer that reads the signal, or you can say the output, okay. The light source uh, is a steady source that will emit light across a wide range of wavelength. So usually we use xenon lamp, okay, as a high intensity light source for both the UV and visible ranges. However, since this is costlier, so we can also use tungsten and halogen lamps, okay. And we can also have two different light sources to scan both the UV and visible ranges, okay. And then we have the wavelength selection. So for the wavelength selection, so we use the monochromator, okay. Monochromator separates the light into a narrow band of wavelengths. So most often it is based on diffraction grating that can be rotated to select the incoming and reflected angles to select the specific kind of wavelength, okay. And then we have a filter, absorption filters. So they are basically made of colored glass or plastic designed to absorb specific kind of wavelength, okay. And also we have, other than these, we also have interference filter, cutoff filter, band pass, okay. So this is all about the the and then also we have the detector, which is here. So the light has passed through the sample. So a detector is used to convert the light into a readable electronic signal. So generally detectors are based on photoelectric coatings or semiconductor, okay. And also we have various types of this, so we'll try to squeeze our discussion. So let us also see, you can see here. So this was all about a brief discussion about the parts of the UV visible spectrophotometer. So you can see here we have a qubit. So you can see this is my opaque surface, and this is my the width of the qubit, which is 1 centimeter, and this is my face, and this is my transparent part. And usually this is for the long path length, okay, and this is for the 1 centimeter path length. So there are different kind of qubits used nowadays, okay. And in continuation, you can see here this is my typical absorbance versus wavelength plot. So you can see we have two lambda max, okay. So it is showing multiple wavelengths, okay. And this is for a specific kind of compound. So usually the spectra looks like this, okay. So depending on the corresponding to the maximum absorbance, we have to choose the lambda max, Okay, and we all know what is absorbance. Absorbance is equal to the logarithm of fraction, that is involving the intensity of light that will pass through the sample, okay, divided by the intensity of light after passing through the sample. Okay, and these are all based on the Beer-Ambed law, and you can see this is a different diagram which is talking about the white light, which is now separate. It's going into different kind of a spectra. Okay, and these are our different kind of light which is showing at different wavelengths. So here we have the higher frequency, and then here we have the lower frequency, and this is my wavelength in the nanometers, so which is lying from the 400 to 800. So, and these are our typical wavelength of the different uh, colors of the light. Okay, and we already talked about the light source, wavelength selection, sample analysis and detection in detail. How do we use a UV visible spectrophotometer? Let's brief it and squeeze it. So here we have a sample compartment, already we saw that. So we have to position it such that it will allow the light to pass, and or you can say allow the beam from the monochromatometer to pass through the sample. Okay, and also, for the measurement of absorbance, liquid samples would typically be held in a cuvette with a known fixed path length. Okay, and we have to also be selective about the cuvette what we are using. It should be rectangular, or also, what should be the dimension of the cuvettes. Okay, so standard cuvettes have a 10 millimeter path length, and usually they are made from quartz. And cheaper plastics can also be used, but we have to be very clear that they generally do not transmit UV light. So classic cuvettes are preferred. Sorry, quartz cuvettes are preferred. Magnitude for special applications are available from cuvette that hold tiny volumes. How much amount of volume we are going to keep in the samples that have to be analyzed. This is also a typical cuvette. So cuvette for measuring liquid samples. So they are 10 mm path length, 3 ml cuvette, ultra micro self, so different kind of cuvettes. And also for the UV range, what kind of cuvette we should use, and this is the wavelength range. We already talked about that. Now in continuation, you can see that we have the different wavelength for the different organic compounds. So for the acetone is 329 nanometers. For the water, you can see it's 180 nanometers. For toluene it's 285 nanometers. This is the lambda max. And the material the cuvette is made from will also have a UV visible absorbance cutoff. Okay, so the glass will absorb all of the light and energy starting at about 300 nanometers. So if the sample absorbs in the UV, a quartz cuvette will be more practically feasible, or you can say more practically better. Okay, as the absorbing cutoff is 160 nanometers for quartz. So glass is 380 to 780, plastic 380 to 780. It's almost synonymous or analogous. For fused quartz is less than 380. Now some of the activities which you can comment or when you see this lecture. So what is a spectrometer used for? What is the basic principle of spectrophotometer, and how does the spectrophotometer work? So don't forget to like and subscribe my channel.